Welcome to the Module 5 of the Python programming course from beginner to advanced. In this module, we will be exploring 4 essential pillars of Python programming: function, modules, file handling, and object-oriented programming. This concept will significantly advance your ability to write, organize, and professional Python code. Module content. This module covers 6 key topics. We will begin with defining and calling function, followed by advanced function techniques, including args, quags, and lambda functions. We will then explore modules and packages, file handling operations such as reading, writing, and appending. And finally, we will introduce object-oriented programming through classes, object inheritance, and encapsulation. Introduction. As Python programs grow in complexity, it becomes essential to organize code into manageable, reusable components. Python provides 4 powerful mechanisms to achieve this. Functions allows block of logic to be defined once and reused many times. Modules enable code to be organized across separate files. File handlings allow programs to interact with external data sources, and object-oriented programming provides a framework for modeling complex systems through classes and objects. Together, these 4 constructs are the foundation of professional Python developments. Defining and calling function. A function is a named, reusable block of code that performs a specific task. Functions are defined using the def keyword, followed by the function name and its parameters. Let us look at several examples. The first function, print_header, takes no parameters and print a formatted header to the screen. The second function, calculate_grade, accept a score parameter and return a letter grade based on conditional checks. Def print_header, open bracket, close bracket, print, open bracket, apostrophe equals to close the apostrophe, then star 35, close the bracket, print, open bracket, Python course result, print, open brackets, equals to 35. Def calculates _grade, open bracket, score, close the bracket. If score is greater than or equals to 90, return A. If score is greater than or equals to 75, return B. If score is greater than or equals to 60, return C. Else, return F. Defining and calling function continuation. The third example power demonstrates the use of default parameter value. The exponents default to 2 if not provided. The fourth example, min_max, shows how a function can return multiple values at once, and these are the examples. Functions follow the DRY principle, which stands for do not repeat yourself, meaning you write the logic once and call it as many as needed. Args, quags, and lambda function. This slide covers advanced function techniques. The first is args, which allows a function to accept any number of a positional arguments. Def calculate _total, open bracket, asterisk price, close the bracket, return sum, open bracket, prices, close the bracket, print, open bracket, calculate _total, open bracket, 100, 250, 75, close the bracket, hash 425, print, open bracket, calculates total underscore total open bracket 500 100 1200 comma 300 comma 90 close the bracket hash 2090. The second technique is quacks, which accept any number of keyword argument as a dictionary. Def display underscore profile open bracket asterisk details close the bracket. For key value in details dot items open bracket close the bracket. Print f open bracket key dot title open bracket close the bracket value. Display underscore profile name equals to engineer Mustafa, role equals to Python specialist CT Kano, hash name engineer Mustafa, role Python specialist CT Kano. So this is how it is going to fire. The third technique is the lambda function. An anonymous one-line function, lambda function, are written using the lambda keyword, followed by parameters and expression. They are especially useful when combined with built-in functions such as sorted, map, and filter. And if you follow this example, that is how it is being written. Module and packages. A module is a Python file with the .py extension that contains functions, classes, and variables. Modules allow code to be organized and reused across multiple programs. Python's standard library contains over 200 built-in modules. There are several ways to import a module. You may import the entire module, import specific function from it, or use an alias for convenience. And for you to use that, you can use, these are the examples that demonstrate the model and the packages, on how to import the models and the packages. So if you follow the example, you will arrive at the final answer. File handling, read, write, and append. File handling enables Python programs to read from and write to external files, allowing data to persist beyond a single program run. Python opens file using the open function along with a module specifier, R for reading, W for writing and overwriting, A for appending, and X for creating a new file exclusively. It is best practice to always use with the statements when working with files, as it ensures the file automatically close after use. And to use this, so these are the examples that demonstrate how you can work with the files, how you can use R to read only, how you can use W to write, how you can use A to append, and how you can use X to create. Classes and object. Introduction to OOP, that is object-oriented programming. Object-oriented programming, or OOP, is a programming paradigm that models real-world entities using classes and objects. A class is a blueprint for creating object. An object is an instance of a class. An attribute stores data within the class, and method is a function defined inside a class that describes its behavior. In the example below, we define a student class with a class variable institution, an instant variable set through the --int construct method. And for you to use the class and object, so these are the example that use the class and object. So if you follow it, you will arrive at the final answer. Inheritance and extending classes. Inheritance allows a child class to acquire the attribute and method of a parent class, enabling code reuse and the creation of class hierarchies. In the example below, person is the parent class. The instructor class inherits from the person and adds its own subject attribute and teach method. The super underscore underscore int and underscore underscore open bracket close bracket call ensure the parent class is properly initialized. So if you follow the example, you will understand how it's how you will understand how it has been done. Encapsulation and polymorphisms. The slide covers two more pillars of OOP. Encapsulation means building data and method within a class and restricting direct access to certain attributes. In Python, private attributes use a double underscore prefix such as underscore underscore balance and are accessed only through getter and setter method. So these are the examples that demonstrate encapsulation and polymorphisms. So if you follow it, you will understand. Polymorphisms means that the same method polymorphisms means that the same method's name can behave differently in different classes, achieved through method covering. The slides bring together all OOP concepts through a practical example, a simple library management system. We define two classes, book and library. The book classes store the title, author, as ISBN, and availability status. The dash dash str underscore method control now the object is displayed when printed. The library class holds a collection of books and provide method to add and check out books. So this is the example that demonstrate that. That is putting OOP into practice. Do and don'ts function files OOP. This slide summarizes best practices and common mistakes to avoid. You should write docstrings for every function and class. Use default parameter values for optimal arguments. Always use the with statement when opening files. Use super underscore ints underscore open bracket close bracket in child class constructors. Use str underscore underscore str underscore underscore open bracket close bracket to make object print friendly. Keep function short and focus. Protect data with private attribute and import only what you need. Avoid writing functions that perform more than one task. Forgetting to close files. Using import which pollute the namespace, accessing private attribute from outside the class, creating deep inheritance chains of more than 3 levels, placing all code in single file, and using mutable default arguments such as list in function definition. Concept at a glance. Let us summarize the 4 pillars covered in this module. Under function, the def keyword define function. They accept parameters and return values. Args and quirks provide flexibility. Lambda function offer concise one-line definition and dry principle guides reuse. Under modules, modules are Python.py files imported using import or from imports. The standard library includes maths, random, and CSV, and packages are directories of related modules. Under file handling, often uses modes R, W, A, and X. The with statement is always recommended, and the CSV model handles structured data. Under OOP, the class keyword defines a blueprint, underscore integer, underscore initialize object. Inheritance extend parent classes, encapsulation protect data, and polymorphisms enable the same method's name to behave differently across classes. Conclusion. This model has provided a comprehensive introduction to 4 Python most important program structures: function, models, file handling, and object-oriented programming. Function from the fundamental units of code reuse. The model system organizes code across file and provide access to Python Bash standard library. File handling extend programs to work with persistent real-world data, and object programming through classes, inheritance, encapsulation, and polymorphisms equips learners with a powerful paradigm for modeling complex systems. Together, these four tools represent a significant step forward in programming capability and prepare you well for the advanced practical and data course model ahead. Key takeaway. Function models, file handling, and OOP are the four pillars that transform basic script into professional software.